Yeah, we start a new topic, wind power. Wind power. So first, what is wind power? So wind power, yes, caused by differential heating of Earth's surface and the atmosphere. Induce vertical and horizontal air currents that are affected by the Earth's rotation and contours of them. That's wind. That's wind. I explain how the wind be generated. And we have a famous wind called land-sea breeze cycle. What is land-sea breeze cycle? Yeah. Next slider. Yeah, here. So you can see, yeah, that here is the land and here is the sea. So during the day, surface of the land is heated by solar radiation and become warmer than the sea. Here, and here is the sea. The contrast between sea and land surface temperature become significant. The temperature difference peaking around mid-afternoon. As warm air rises over the land, a local circulation current began because here is warmer and here is colder, so they got circulations. And then drawing the cool air in from the sea, And instantly, air return to seaward in upper return current, like this direction, and increasing momentum of the cycle and spreading the effect over a greater area of land. So typically, the wind turbine, we can see, they always appears close the coast or by the sea. So at least they got this wind cycle. This is land-sea wind cycle. We call breeze cycle. What is the wind power? As we know, it is renewable energy, no greenhouse gas emission, and winds are influenced by the ground surface at altitudes up to about 100 meters, and wind is slowed by the surface roughness and the obstacle. When dealing with the wind energy, we are concerned with surface wind. And you can see we got a wind turbine here. A wind turbine obtains its power input by converting the force of wind into a torque, turning force, acting on the rotor blade. And the amount of energy which the wind transfers to rotor depends on the density of the air, the rotor area, and the wind speed. We have mentioned this formula. That's our. And as you can see, this is a typical wind turbine rotor diameter. For a typical 600 kilowatt wind turbine, it's about here, 600 kilo wind turbine. its rotor diameter is about 40 meters here. It's about 43 to 44 meters. And the area, rotor area, some 1,500 square meters. And the rotor area determines how much energy a wind turbine is able to harvest from the wind. So its wind power is proportional to its area, the rotor diameter swept area. So you can see here is the area, and like a previous slide, like here, like here. When the wind turbine start to rotate, its area is like this circle. And okay, how does wind energy work? First, wind produce via an even heating of the earth, and then we got the wind turbine. So the kinetic energy absorbs from the wind, and make the turbine wind turbine brake, and then make the shaft to spin. So the kinetic energy is transferred into mechanical energy. And then the shaft of the generator are coupled with the wind blade, turbine blade. So once the wind blow make the wind blade rotating, so the rotor of the generator also start to rotating, and then we got the mechanical energy transfer into electrical energy. And next is about the typical wind turbine components. First, I think it's most important is its blade or with rotor, which convert the energy in the wind to rotational shaft energy. That's the blade. The blade is like this. And then you can find this. This is its blade. Blade. And next, tower. The blade must be supported by the tower. So there, not just blade. So tower that support the blade and rotor and the drivetrain. Drivetrain. Later we can show you what is drivetrain. Maybe now. Here is the drivetrain. Here is the rotor, and this is the drivetrain. And also, for wind turbine, wind machine, we have other equipment like control system, electrical cable, ground support equipment, and also interconnection equipment. Later, we will give more detailed description about this equipment. And we have drivetrain, usually including a gearbox and a generator, because I think it's also important for wind machine system. the wind turbine, when we watch the rotation of the wind turbine, yeah, it's a rotating speed. Yeah, it's not so quickly, not so quickly. However, yeah, the generator, yeah, the conventional generator, traditional generator, yeah, it's a high-speed rotations. It got the higher speed typically, yeah, for industry's motor or generator. Yeah, it's maybe running at 3,600 RPM or yes, 1,800 RPM. RPM. So it's a high-speed rotation machine. However, yeah, the wind turbine, yeah, it's running at a slower speed. Maybe about 20 RPM. 20 RPM. And the other, yeah, generator, yeah, is 3,600 RPM. So, yeah, that's different speed for wind turbine. Another is a generator. So it's different speed, different speed. So how to make them together? Yeah, here we use this gearbox.